Alright, here we are on page 4, and I want to go through just a couple more scenarios with you. So these are a couple more try problems. I'd like you to try both of these, number 50 and then number 48. And then we're going to talk about what happens here in a little bit. So go ahead and hit the pause button, follow the steps, get some practice on these. I would definitely recommend showing your work on this one, and then come back and we'll see what happened. Okay, so hit pause and try number 50 and number 48. Okay, hopefully you had a chance to try these. If not, please hit pause. It's really a good exercise to walk through these on your own, because when you do, you'll discover that something unexpected happened here, and we're going to talk about what happened. Let's walk through these together. This is one of those unique situations where I do want to go ahead and walk through these in the notes with you. Number 50, again, if you haven't tried these on your own, please do. Hit pause, try them, come back, and then we'll do them together, okay? Okay, so on number 50, I'm seeing parentheses, so I'm going to go ahead and distribute to get rid of those parentheses. So I get 3x minus 3 times 1, or just minus 3, equals the 8x plus 6 minus 5x minus 9. Then I look to combine like terms, and on the right side I have both x's that I combine. 8x minus 5x is 3x, and then I also have constants, just plain old numbers that I can combine, 6 and minus 9, which gives us a minus 3. And I still have my 3x minus 3 on the left side, because I was just combining like terms on either side. Next, I'm looking to pick a side for x, and again, it doesn't matter. I'm going to go ahead and just subtract this 3x that's on the right side, and I'm subtracting because the sign in front of it is a positive. It's a positive 3x, so I need to undo that by subtracting 3x from both sides. And what happens is the 3x minus 3x also goes away on the left side. So when I take it away from the right side, and then I take the same thing away from the left, it only leaves me with negative 3 equals negative 3. Some of you might have continued with that and added 3 to both sides, and you may have ended up with a even all the way to 0 equals 0 if you were to consider adding 3 to both sides. Okay, so what happened? Well, all the x's fell away. Okay, so all the variables disappeared when we followed our steps. We didn't do anything wrong. All our x's disappeared. And what we ended up with was 0 equals 0. We ended up with a true statement. What that means is that no matter what value I put in for x into this original equation, x is always going to fall out as you start to move things around, and you're going to be left with a true statement, which means that x can be anything. Okay? When we solve an equation, we come up with an answer saying this is the number that you can put in for x, and it makes it true on both sides. In this situation, when you start to solve and all the x's disappeared and you ended with a true statement, what that means is that no matter what x, no matter what value is put in for x, no matter what value is put in for x, it's going to be still a true statement. I'm abbreviating statement there. Okay, so that means x can be anything. You can pick any number for x, and it will work in this equation. This is known as an identity, an equation that it's true no matter what. It's true no matter what you put in for the variable. And so our answer in set notation, we'd put the little sets, again, the little braces, and you could say all real numbers are your answer. Any real number that you put in here, which means it could be a fraction, a decimal, a negative, 0, or just a regular natural counting number. It could be a rational or an irrational, a decimal that doesn't end, doesn't repeat. Anything that you put in here is going to always end up with a true statement. And so all answers are possible on this. So let's go back and look at what happened then with 48. Hopefully you tried this on your own, okay? And I didn't want to leave you struggling with it. I wanted to walk you through to see what would happen here together. So you've tried it, and now maybe you kind of get a hint, seeing what I talked about here. What does it mean when everything goes away and you're left with a true statement, like -3 equals -3 or 0 equals 0? You might be able to now draw some conclusions about what happened for you on number 48. Let's see what happened. Need to distribute because there's parentheses. That's the first thing we check for. Simplifying, parentheses, like terms. So parentheses here, 2 times x is 2x. 2 times the -5 is going to be a -10 equals the 2x plus 10. No like terms on the left side to combine. No like terms on the right side to combine. So we need to pick a side for x. I'm going to move to the right side this time in front of the 2x. There's nothing, so we assume positive. We do the opposite, which is minus. What we do to one side, we do to the other. They go away. That was the whole point on the left. We're left with -10 equals. They don't go away, they do go away on the right side as well. And this is where it's a little unexpected. They cancel on both sides when you subtract it to try to move it. And you're left with just the plus 10. So you've got -10 equals positive 10. Or if you took it one step further and added 10 to both sides, you might end up with 0 equals positive 20. Okay, again, what happened here? Well, what happened was all the x's disappeared again. Only this time we ended with a false statement. Last I checked, 0 did not equal positive 20, and -10 did not equal positive 10, okay? So that's a not equal situation. This is definitely an equal situation on the first time. So, well, what does that mean? That means when it ended up in a true statement, it meant that no matter what values put in for x, you'll always get the identity, the same thing. And so x could be anything. But here, false is opposite of true. That means the opposite is the meaning as well. So that means that no matter what value is put in for x this time, you're left with a false statement because everything will fall out. And that means that x can't be anything. There's no solution for x. So this one means that no matter what value is put in for x, what you get is a false statement. There's nothing that will make this equation true. There's no x you can put in that won't go away and leave you with a false statement. So that means that x can't be anything, which another way of saying that is that x has no solution. Sometimes you write that with a 0 with a little slash through it, kind of a sideways slash, diagonal slash I should say. So this type of equation where it's true and all real numbers work as your variable, that's known as an identity. This one is known as an inconsistent equation. There is nothing that will work. We can't solve that. Okay, so I wanted to walk those through with you, and then we'll see at the bottom of the page for a practice plus. Good job.